Hey folks, welcome back to the video. So today I kind of want to talk about the design that I have and the design we were using previously before we move deeper into the technical aspects of things. Okay, forget this. 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's go. 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's go. Hey folks, welcome back to the video. So today I kind of want to talk about the setup that I have going forward. So previously what we had was we had a single node Kubernetes cluster where our control plane and data plane was on the same node. So all of our data plane pods and everything to do with control plane was in the same single node, right? But going forward now, I'm going to change my setup. So this will be my setup going forward, and what I have is in my local desktop I will be installing all the control plane components. Alongside I'll have Microfana, Prometheus stack, and then NVIDIA plugins and everything to do with the GPU feature discovery in my control plane. After that I will rent a machine in Vast.ai that will host my data plane. There I'll just have the VLLM pods and my UI pods. So this way it will be much easier for me to expand my cluster, because initially what was happening is every time I was done with my GPU node, I had to rebuild my control plane cluster again and again. But now since it's my local desktop, I don't have to do these parts, I don't have to repeat these parts, right? But for my data plane, I'll just rent a new machine and then I'll just add it in my cluster as I need it. So kind of to talk about what made this happen in an easy way, right? Because if you think about it, my local desktop is in a completely different network, and then these GPU machines are in a completely different network, right? And even in Vast.ai, what happens is like no two GPU machines are in the same network, right? They are in a completely different networking setup. So to solve that problem, we have this concept called Tailscale. So essentially what Tailscale does is that once you do the setups, what it does is it will kind of weave all of your machines into one network. So to do that, what it does is it assigns a virtual NIC to each of the machines that you have it set up in Tailscale, and then all of these machines will be binded in the same network using the Tailscale backend network and everything kind of like their setup, right? So now with Tailscale, all of your machines, even though they're in completely different networks, will kind of appear in the same network. And because of that magic, we can make kind of our Kubernetes cluster work, right? So if you haven't used Tailscale before, it's free to set up, and then it's not just like machines from Vast.ai. You can link machines from many other cloud providers or containers as well, different kind of operating systems. So you can link all of your machines in the same network. It kind of solves these kind of problems. It's safe, it's secure. Have a look more about Tailscale. It kind of it solves a lot of other problems too. So for our setup, what we need to do is just go to settings and then go to keys. So once you go here, you can create an auth key. So once you create an auth key, you don't need to log in again and again in your machines. So that's what I've done. I've generated an auth key, and then I've defined that as an environmental variable in my machine. So let's go ahead and get the setup done. So on the top here, this is my Vast.ai machine. I've already cloned my repo, the GPU Vast.ai. So I'll go to GPU Vast.ai, and then this is the multi-node cluster setup, local control plane. So there are a bunch of files here, right? So if we look at the README, it kind of tells you what each script does. So each script has its own purpose that you will need to set up the local control plane. And then the second shell here, this is my local desktop machine, right? So sorry, hostname. Yeah, so this is my local desktop machine, and then what I've done is let me just go to the path here as well, and so I've already installed everything that I need to install, like local control plane.sh, dependencies on init control plane, and then the monitoring bits. So after doing all of that, what I have here now is if I go kubectl get pods -a, you can see that I have my GPU feature discovery, all of my NVIDIA related parts, and then my control plane parts. They're already running in my control plane machine. So if I go kubectl get nodes, you'll see that I have my node here. And just an observation, right? It's usually, like in production, it's recommended not to run anything apart from control plane stuff and your control plane node. But this is a lab setup, and I kind of want these things to be persistent. That's why I'm running these in my control plane as well. But generally, you would only run the control plane stuff in control plane nodes. None of these monitoring and default namespace pods or deployments should be in your control plane node. But in this case, it's different, right? So once you run all of these things, it will set up the local control plane for you. And once those things are done, what I need to do in my worker machine is, all I need to do now is I need to run my worker node prep.sh, and that is enough. But before doing that, we need to define, you need to do like, export, and then let me actually give the script as well. So this is the environment variable that Tailscale is using in the script. So you need to define that. So just do kind of like export, and then ts underscore auth key, and then whatever value that you get from your Tailscale. So now I will, the other thing that I kind of wanted to show was in my machine here, I already have Tailscale set up as well. So you can see that that is my Tailscale IP. Okay, so to make this worker node join our cluster, we have to run the script. Make sure to export your ts underscore auth key, the Tailscale auth key, so that the script will run with no issues. After you define the environmental variable, you need to run sudo -e so that we preserve the environmental variable, and then the script is worker node prep.sh. It'll ask for a hostname, so I will just copy this. Okay, we can see here, right? So it was kind of connected using the Tailscale auth key that was defined. It is connected, got the IP, and it's now doing the other parts to install the containerd. So we'll keep running this command here, kubectl get nodes -watch. Okay, so we see that the script is completed, right? So to make this node join our cluster, we need to get the join command printed. So if you use the script through the setup, you will kind of get the this file created here, or we can just run the kuvadium join command, so the print token command here as well. So the command to get that token created is kuvadium token create and then print join command. So we'll get this one. So it kind of says here, right, kuvadium join, and then use this token to connect with this machine. So let's copy that. And actually, before we do that, right, what we can do is we can check our Tailscales and see that if the other machine is connected here or not. So we can see that in our Tailscale network, now we can see our Vast worker 1 is connected as well. So we can try and ping it, 100.65.45.127, and we get a response back as well. So these two machines are in the same network now. And then let me run this command, kubectl get nodes -watch. So far I only have one node, so I'll run this kuvadium join. So it goes through a bunch of setup parts, right? So once those setup parts are done, there we go. So the node has joined our cluster. So for the node to be ready, there are a bunch of other things that needs to be installed, like the CNI plugins and other things, so that the node is visible in our cluster. So we can see if it is ready now. Okay, yeah. So we see that our node is ready as well. And if I run this command, kubectl get pods, the -o wide -a, sorry, kubectl get pods -o wide and all namespaces. So we can see there are a bunch of pods already being installed on Vast worker 1, right? So Prometheus node exporter exports all the matrix about the node. and then we have the kube proxy needed for Kubernetes networking, and then we have the Calico node, it's the CNI as well, and then we have the GPU operator, right? So that is an important part for us, which exposes all the GPU related metrics. So this is this GPU node.sh. So that kind of installs a Helm repository, and I actually already ran this on my installation, but if you were to follow along, just run that. Once you run that, that is the kind of Helm repo that it installs, and then every time a GPU node is detected, right, it goes and it installs that, and it checks that, okay, can I expose the GPU or not? So let's see if we can see all of our containers are ready. So the GPU feature discovery is still on pod initializing. So, and there are a bunch of other pods now going into Vast Worker as well. So we can actually do this. Okay, yeah, so most of the pods are already running now. CUDA validator just goes in, does its job. Once it's completed, it goes in a completed state. So now we have a Kubernetes cluster that has nodes from completely two different regions, and then we are ready to use this node, right? So it says that ready, but scheduling is disabled. So let's have a look on why the scheduling is disabled. And kubectl, yes, describe node. Okay, so is now not schedulable. Okay, it looks like it went through a GPU driver upgrade. That's why it says that the node is not schedulable now. So we can make this node schedulable. I'm pretty sure the upgrade has been completed, or let's see if we get any further logs. So this is usually a first time setup behavior, which is pretty normal, to be honest. We can check if all the pods are completed or not to confirm that as well. So we'll see kubectl get pods -a -o and then let's again grep for the worker. Okay, so we see all of our pods are completed, right? So the GPU driver upgrade is completed as well. So now let's get our node again, kubectl get nodes. Okay, so still says it's scheduling disabled, and even though all of our pods are in a complete state. Okay, so what I can do is I can either wait for this to come back to being a ready and scheduling, or I can manually make this schedulable. Okay, so one more time to see if it comes back up naturally. Scheduling disabled. Yeah, I think since it might be taking some time for some other pre-checks to complete, but what I know is if I run kubectl get pods, all of the pods are completed, right? So the GPU upgrade is done. I'll run the get nodes one last time. Okay, it still says it's scheduling disabled. So all I'm going to do now is I will uncodon the node. So uncodon Vast worker, that's one. So the node is now uncodoned. If I run get nodes, I can see that node is ready and it is schedulable. So now to test our pod placement, to see if this pod actually gets placed in our worker node or not. So what we need to do is there's actually one more thing that we need to do, right? So this is one of the ways that I want to go. We have to level our worker node as worker, and then all of the further Kubernetes pod will be set up in a way that it says that preferably go to worker nodes. So for me to do that, I can just copy that command here and then just replace the worker node name with my actual node name, which is Vast worker -1. I will kind of in my future comment, I will set up this in the script so that we don't have to label it manually. So the node is now labeled, and then I have the GPU test.yaml. So let me run kubectl apply -f GPU test.yaml. Okay, it's kind of saying that. Let's have a look. Why is it complaining? GPU test.yaml. Okay, it's complaining about, I'm pretty sure it's complaining about the setup here, the YAML. So let me go here and then delete this. So let's try again. Okay, it looks like there must be the node selector. Oh yeah, okay, so I need to open this here and then mention node selector and then wrap this inside node selector and node-role.kubernetes.io.worker. Okay, this space shouldn't really make a difference here, but okay, let's see. So kubectl apply -f. Okay, yeah, there we go. So that was the only part that was missing in the YAML, and the pod is created. So let's get kubectl get pods -o wide. Okay, so we can see that GPU -test is getting scheduled in our Vast.worker 1. Just wait for the pod to get ready. Okay, so the pod is now ready, and what I'm going to do is I'm going to get logs from this pod to make sure that it is running as expected. Okay, yeah, so these are the pod logs from my GPU that was rented from Vast.ai. So this pod just runs NVIDIA -SMI in a loop. And yeah, this is where I kind of want to conclude the video. And again, going back to what we did was essentially, you know, we're trying to separate our control plane and our data plane. So for control plane, we'll use our I'll use my local desktop, right? So everything stays permanent. I don't have to rebuild my cluster again and again. For data plane, just rent a GPU node from Vast.ai, and then we'll install all of the GPU related pods there. And the reason all of this was made possible is because of Tailscale. Using Tailscale, I assign my local desktop and my GPU node in the same network. Once they're in the same network, then I can add them in my Kubernetes cluster. So I hope you guys had fun watching this video, and thank you.